Welcome to your sixth ACT Math video. Thank you for rejoining me. So in this video, you have 7 questions that I want you to take 8 minutes to practice. So at this time, just like before, please pause the video, set a timer for 8 minutes. Once those 8 minutes are up, then please restart the video and we can discuss through the answers together. So again, please pause the video now. So now that you've seen all of these, now let's go through and talk about what strategies will best help you through these types of questions on the ACT. For this first one, simplifying a complex fraction. So what you're going to want to do is you're going to want to get a common fraction on top, a single fraction on top, and a single fraction on the bottom. So on top, to get a single fraction, we need a common denominator. The common denominator is going to be 2x. So this is going to need a 2 over 2 on this side and an x over x on that side, ultimately giving us a 2 plus x on top with a denominator of 2x. On the bottom, this side is going to need an x over x. This side is going to need a 3 over 3 to get a common denominator. Well, that's going to give us an x squared plus 6 on the top and a 3x on the bottom. Hopefully you remember from here that when you're dividing fractions, it's the same as multiplying by the reciprocal. So what this means is I have that x plus 2 divided by 2x, and I'm going to multiply it by the reciprocal of that bottom function, or that bottom fraction, sorry. So I always like to put parentheses around those so you realize that they're an entire unit. These x's out there, those x's are going to be able to cancel off. And then finally, you notice in all of your answer choices that you don't have anything in factored form. So what that means is you want to redistribute these things out. So I'm going to redistribute the 3 on the top. And I'm going to distribute this 2 along the bottom. When you do that, you are going to see that that is answer choice A. Again, the big idea here is just making sure that you know how to get common denominators, that when you divide, you are multiplying by the reciprocal. In number 24, they tell us that this is a linear function, and they want to know what is the value for f of -1. So basically what they're concerned with is finishing that block right there, okay? Where is my function when x is -1? Telling us that this is linear is actually very, very important to us because linear functions change with a consistent rate of change. So what that means is to go from here to here, I'm subtracting 3 off. So for something that's linear, it means that is the pattern that is always going to occur. So that means I'm going to subtract 3 again to get to there. Subtract 3 again to get to there, and then a nice check is when I subtract 3 again, I do get that -4. So that kind of confirms that I'm on the right track because that lined up perfectly. And the solution I'm getting, what is f of -1? It's actually going to be -1 because that's what I got inside there. For the last one on this page, this is a notation for composition of functions. When we're doing composition of functions, remember, I always like to start in the middle, okay? I want to figure out what is that g of 5 first. All right, start in the center. Well, g of 5 is going to give me 10 minus 1, or is going to give me 9. So I can replace g of 5 with the number 9 in there. So ultimately, what I actually want to find is what is f of 9, all right? So I'm going to plug 9 into that other function now. So 3 times 9 squared plus 9. So 3 times 81 plus 9. 243 plus 9, or that is ultimately going to give you 252 as your answer, or that is going to be option E. Number 26. Ainsley has 23 coins in her purse. If the total value of all of her coins is $1.50 and she only has nickels and dimes, how many dimes does she have? So here, I'm actually going to use a little bit of a shortcut that I would definitely recommend when you're solving these types of problems on a multiple choice test. All right, so they're asking us, how many dimes does she have? Well, so in letter A, if she has 5 dimes, that would equate to having 18 nickels, correct? So now I'm going to use my calculator to help me with this. So if I have 5 dimes, dimes are each worth 10 cents or $0.1, and 18 nickels, which are only 5 cents or 0.05 of a dollar, that's only giving me $1.40. In the problem, however, it told me that I wanted $1.50. So that means A must not be my answer. So let's go to D or B. If I have 7 dimes, now that means I have 16 nickels. So let's check out the value of having that. All right, so now I have 7 dimes, each worth 10 cents, and 16 nickels, which are each worth 5 cents. Now I'm getting that $1.50 that the problem told me that she had in her purse. So that's a very powerful strategy of, in this instance, letting the answers kind of guide you to what the solution is. And using the answers, I much more quickly got to check which one was right. 27. Number 27 is another one where we need to talk about common denominators, much like what we did back in number 19. But here for common denominators, again, let me toss on my parentheses here. So for my common denominator, that 3x over x plus 4 is missing this denominator. So that side needs an x over x. And my 4 over x is missing that x plus 4. So that's what it needs in order to achieve its common denominator. So let's take a look at what that means. My first fraction, x times 3x, is now going to be 3x squared. And when I factor in that x, that gives me x squared plus 4x. In the second one, when I distribute in the 4, I get a 4x plus 16. And on the bottom, I get that common denominator. There was the whole point of doing this. If I didn't have the same denominator, that would tell me I was likely doing something wrong. However, since I do have a common denominator, what that means is I can simply add the tops together. And it's over that common denominator. And if you look at your answer choices, that is exactly what C is giving you. For number 28, if you FOIL those two pieces together, that is precisely how you work through that type of problem, okay? You can FOIL it out. However, in terms of the ACT, obviously this is a timed test, so it's also very beneficial for you to recognize the resources you have in front of you. So if you recall, when you're dealing with imaginary things, this button right down here actually is the imaginary number I. So your calculator is actually installed with the ability to handle these imaginary computations. So let's go and use that command. So 5 plus I. To get to I, you need the second key. then 5 minus I. And if you type that in, it will automatically get you that answer of 26. So for that one, it is to your benefit to understand the resources you have out there. Again, factoring would, or foiling it out would be the best way to get there. However, in the time constraint, you're going to want to know that resource of just being able to use the calculator. For this last one, what is the missing term in the following geometric sequence? So here, knowing it's a sequence means we're doing the same thing over and over and over again to generate the terms. Now, geometric even tells me a little bit more. Geometric means that the sequence is being produced by multiplication. Okay, I'm multiplying by the same thing over and over and over again to find the next terms. So, how does this help me? Well, that helps me because I know that going from 48 to 192, I'm multiplying by a certain number, okay? So we need to figure out what that number is. So the easiest way to figure out what you're multiplying by to go between those two numbers, ironically, is actually dividing those two numbers. So, because what this is telling me is 48 times 4 is giving me the 192. So to go from term to term to term, I'm multiplying by 4. Well, that means to go from here to here, I'm also multiplying by 4, and that will simply give me the number 12. So thank you for watching these with me. If you have any other questions, please feel free to come either see me or your math teacher so we can continue to clarify any misconceptions that you may have.